Presently in service on U.S. Navy and Marine aircraft are three basic Gatling guns: the 6-barrel 20mm M61A1 Vulcan, the 3-barrel 20mm M197 lightweight Vulcan, and the 6-barrel 7.62mm GAU-8, better known as the minigun. Basic design, engineering, and logistics support for these weapons are provided by the Pacific Missile Test Center, Point Mugu, California, the Navy Cognizant Field Activity for Aircraft Gun Systems.
Captain R.K. Skerritt, USS John Paul Jones. Sir, I am writing you, sir, to appraise you of what is undoubtedly the most remarkable event of my assignment to Washington after serving over 2 years under you on the John Paul Jones. An event, sir, which I think you will also be interested in. It is in my present position as testing officer at the Navy Yard that I have come across a most unusual and extraordinary weapon called the Gatling. I have found this Gatling so impressive, even astounding of performance, that, please do not think me crazy when I say this, that I can envision the day when every Navy craft will have a Gatling aboard.
Today's Vulcans and miniguns are marvels of high-speed material handling. Gun firing rates of up to 7,200 shots per minute can be tailored to any application. Since the firing operation of these guns is based on simple rotary motion, reliabilities far surpass any other conventional machine gun, making the Vulcans and minigun the most reliable high-rate-of-fire weapons in the world. Operation of the two Vulcan guns and the minigun is based on the Gatling principle.
Ready to fire! 1, 2, 3!
In the modern-day Gatling, the main moving parts are a rotating barrel cluster, a rotor, and a gun bolt for each barrel. The gun barrels are attached to the rotor and turn in unison. Each gun bolt is free to slide fore and aft on tracks in the rotor. Positioning of each bolt is determined by a cam follower, which moves within a cam path machined in the stationary outer housing. The cam path causes each bolt to ram, lock, fire, unlock, and extract its round. The smooth motion of the bolts as they follow the cam path, to a great extent, accounts for the high reliability of modern Gatling guns. All motion within the gun is smooth and continuous, resulting in low parts stress, as contrasted with the high velocities and stresses found in most single-barrel machine guns. The 20mm M61A1 and M197 fire electrically primed ammunition, while the 7.62mm minigun fires percussion-primed ammunition. Also contributing to long gun life and high reliability is the fact that each barrel and bolt combination fire only once during each revolution of the gun. This means that the total number of rounds fired are divided equally among each of the gun barrels. The reliabilities of these gun systems on various aircraft are compared in this chart. The basic M61A1 gun has a 150,000 mean rounds between stoppages, MRBS, as compared to the specification requirement of 10,000 MRBS. The M197 has a 60,000 MRBS against a spec of 10,000 MRBS, and the minigun of 400,000 MRBS against a spec of 15,000 MRBS. The figures clearly demonstrate how dependable the Gatling principle really is. Overall, system reliabilities are also high, the UH-1N minigun pintle being the most dependable, with a 78,000 MRBS versus a specification of 10,000 MRBS. These numbers can also be converted to a reliability factor, which represents the probability of successfully firing a burst of 115 rounds without a stoppage. Here, too, Vulcan and minigun armament systems have consistently demonstrated high dependability, with reliability factors in all cases well over 98%.
Admiral Dahlgren told me he regarded this weapon the most effective implement of warfare invented during the war. On this point, I must agree with the Admiral. I found the mechanism simple and not likely to get out of order, but in such event it could be repaired on board ships. Spare pieces, as in musket locks, could be part of the outfit.
The Vulcan, lightweight Vulcan, and minigun are easily maintained weapons. Gun bolts and barrels can be removed for service without major gun disassembly, and often without removing the gun from its mount. The best-known Gatling of them all is the M61A1 Vulcan. Versions of this gun have been in the military inventory since 1955, making the Vulcan the most widely deployed gun system in the history of armament. The Vulcan and derivatives of it have found applications not only on high-speed aircraft, but also in gun pods, land-based towed and self-propelled air defense systems, and a shipboard air defense turret. The mainline attack aircraft for the Navy for almost 10 years, the carrier-based A-7E Corsair, entered combat service in Southeast Asia in May of 1970. It was in this conflict that the M61A1 Vulcan aboard the A-7E saw most of its combat duty. Available space within the Corsair's airframe dictated that the Vulcan gun be placed below and to the port side of the pilot, while the linkless ammunition storage drum was placed directly behind the pilot. Interconnecting the gun and ammunition storage drum are flexible ammunition shooting and a flexible drive shaft. The ammunition system holds 1,019 rounds of 20mm ammunition. The Vulcan armament system is driven by hydraulic power supplied by the aircraft and can fire at rates of either 4,000 or 6,000 shots per minute. The Vulcan aboard the A-7E has shown itself to be an effective and reliable weapon for the close-in support of ground forces. The F-14 Tomcat is the most advanced fighter aircraft ever to leave an aircraft carrier's deck. With a primary mission of fleet defense and secondary mission capabilities of ground attack of tactical targets, the Tomcat places unique demands on its armament system. In the F-14, the Vulcan gun and ammunition storage drum are located port of aircraft center and directly below the pilot. Gun and ammunition storage drum are essentially in line, minimizing drive shaft and flexible ammunition shooting lengths. The linkless ammunition storage system holds 676 20mm rounds. As with the A-7E, the F-14's Vulcan gun fires at rates of 4,000 to 6,000 shots per minute. Test firings at target drones and strafing passes on ground targets have confirmed the Vulcan's dependability and accuracy on the Tomcat. Presently under development, the McDonnell Douglas Northrop F-18 promises to be the most efficient and effective multi-mission strike fighter ever to serve the Navy and Marine Corps. A reconfiguration of essentially the same M61A1 Vulcan gun system as in the A-7E and F-14 The F-18 Vulcan system has the gun located on the vertical center line of the aircraft and directly in front of the pilot. The linkless ammunition storage system is directly below the gun. The current design approach in the F-18 will be with all gun system components joined to a pallet assembly. The pallet assembly will then in turn be mounted to the aircraft. These scenes are taken of the YF-17, prototype aircraft from which the F-18 was derived. Major maintenance to any portion of the gun system will be accomplished by detaching the pallet assembly and subsequently lowering the entire weapon system out of the aircraft. Firing rates for the F-18 Vulcan will be 4,000 and 6,000 shots per minute. By using the M61A1 gun system, the F-18 is assured of combat-proven high rate-of-fire weaponry for missions through the year 2000. The linkless ammunition storage and feed systems used on the A-7, F-14, and F-18 function on the same basic principles. Ammunition is held radially within a cylindrically shaped drum and is able to slide on fixed drum partitions. Ammunition is forced forward along the drum partitions by the revolving motion of an inner helix. An exit unit inserts the rounds into a closed-loop conveyor. The conveyor transports the rounds to the gun and returns the spent cases to the drum's rear entrance unit. Spent cases are reinserted in the drum for downloading later. This system maintains positive control of all live and spent ammunition, thus increasing gun system reliability many times over linked systems. To provide effective ground support for these fighter aircraft, the United States Navy has recently procured a new linkless ammunition loading system called LALS. The LALS is designed to eliminate the use of links in aircraft loading and reduce aircraft turnaround time. It also provides RADHAZ protection and permits greater shipboard storage of bulk ammunition. The LALS uses a double-ended linkless feed drum similar to the Vulcan ammunition storage drum mounted on fighter aircraft. In operation, the LALS loads fresh ammunition in the aircraft at a rate of 400 rounds per minute, while at the same time returning spent cases and unfired rounds to the LALS drum. Similar in operation to the M61A1 Vulcan is the M197 Lightweight Vulcan, a 3-barrel 20mm lightweight version of the M61A1. The basic M197 Gatling weighs less than 150 pounds or 100 pounds less than the M61A1. It has firing rates from 750 to 1,500 shots per minute. These characteristics combined give this gun a number of important aircraft applications. The M197 Gatling is employed on the Marine Corps' AH-1J and T Cobra helicopters. Designed for flight operations in the forward battle area, the Cobra uses its M197 to suppress enemy fire and attack armed personnel and unarmored or lightly armored vehicles. In the AH-1J, the M197 gun is mounted in a high-performance electric turret and has a design firing rate of 750 shots per minute. The gun is driven by an electric motor. Ammunition is fed to the gun in linked form through flexible shooting attached to the ammunition storage container. The ammunition storage container holds 750 rounds of 20mm ammunition and is a product of extensive testing and design improvements which have led to a reliable, simple, and lightweight design. Turret control is provided by a stabilized pantograph sight aimed by the ship's gunner. The 20-millimeter firepower provided by the M197 gives the Cobra the standoff range and reliability necessary to maneuver in the mid and high-intensity battlefield environment. Also equipped with an M197 lightweight Vulcan in a turreted application is the Marine Corps' YOV-10D night observation gunship. This research and development system is similar in design and operation to the AH-1J turret. On the YOV-10D, however, fire control is provided by a forward-looking infrared sight called FLIR. This is actual FLIR imagery as taken in night firing trials conducted at Patuxent River Naval Air Station, Maryland. Again and again, the turret-mounted M197 lightweight Vulcan demonstrated excellent firing accuracy and dependable operation. While turret uses are unnatural for the lightweight M197, this weapon has also found applications in the Navy's new lightweight gun pod, designated the GPU-2A. Designed for light fixed-wing aircraft and helicopters, the GPU-2A offers a lightweight, self-contained, high-rate-of-fire gun pod for such aircraft as the A-4, AH-1J, OV-10, and AV-8A. The GPU-2A is comprised of 4 sections. The forward fairing is an aerodynamic shell covering the barrels and lower portion of the gun. The gun support section forms the structural backbone of the gun pod. To this section, the M197 gun and ammunition conveyor are mounted. Also in this section are lugs for mounting the pod on a suitable aircraft rack. The ammunition storage drum holds 300 rounds of M50 series 20mm ammunition in linkless form. The aft fairing of the GPU-2A houses the pod electrical controls and power supply. Loading of the ammunition storage drum is accomplished through the aft fairing. The GPU-2A is a fully self-sufficient system, requiring only a simple trigger signal from the carrying aircraft. Firing rates are selectable at either 750 or 1,500 shots per minute. A completely loaded GPU-2A weighs only 585 pounds, while the empty weight is 417 pounds. An empty GPU-2A is light enough to be installed on an aircraft without lifting equipment. The U.S. Navy has conducted comprehensive flight and evaluation testing on lightweight pods on the A-4. AH-1J, OV-10, and AV-8A. As a result of these firing tests, the GPU-2A demonstrated a very tight dispersion pattern and effective range of over 2,000 meters. Other aircraft having undergone flight evaluation are the A-7E, F-4, and A-37. The smallest Gatling gun in Navy Marine service is the 7.62mm GAU-8. A small caliber derivative of the M61A1 Vulcan, the GAU-8, also known as the minigun, weighs only 35 pounds and is less than 30 inches long. The minigun fires percussion-primed ammunition at rates up to 6,000 shots per minute. The GAU-8 can be found on 2 Marine Corps helicopters, on the AH-1G in a turret similar to the AH-1J turret, and on the UH-1N in a flexible pintle mount. Designated medevac, UH-1N helicopters equipped with minigun pintles have recently been deployed worldwide. These helicopters are designed to provide quick medical evacuation to wounded soldiers and airmen. The UH-1N minigun pintle system consists of the 7.62 millimeter minigun, a flexible pintle, a specially designed brass disposal system, feed shooting, and the ammunition storage system and control box. The ammunition storage system can accommodate up to 6,000 linked rounds. The minigun provides the defensive strength necessary to enable the UH-1N to enter hostile territory on rescue missions. With the 7.62 millimeter minigun, the inherent reliability of the Gatling mechanism reaches its highest point. Years of field use have shown the minigun reliability to be over 400,000 mean rounds between stoppages.
Admiral Dahlgren, I am told, has since given permission to the commanders of fleets and squadrons to order Gatling guns for their use. It is to this end that I write you, so that you may be ahead of other captains in your fleet in ordering this most destructive of weapons. I am your obedient servant, A.J. Malden, Lieutenant Commanding, United States Navy.
The Vulcan, lightweight Vulcan, and minigun. Versatile, reliable, effective, based on design principles over 100 years old, perfected with today's modern technologies for the present and future needs of the Navy and Marines.
Postscript. R.J. Gatling, the inventor of the gun, told me of a new Gatling he is working on, which will be able to fire at twice the rate of the gun I tested. This would be over 400 rounds per minute. Incredible. While I admire Mr. Gatling, I doubt if even he can design a weapon to fire at such a pace.
In 1990, this quiet beach was transformed into a war zone. Saddam Hussein had invaded Kuwait, prompting a coalition of countries to combine forces to expel his army. Iraq had over 500,000 frontline troops with another million in reserve, armed with a formidable array of Soviet weapons, including 5,000 tanks. The USAF had an aircraft in their inventory designed specifically to obliterate Soviet armor and provide the much-needed support for the coalition ground forces, the A-10. Curiously, General Hornet, commander of air operations, almost left it behind.
General Hornet was called in by General Schwarzkopf before the actual assault launch to review what airplanes were going to be there. 1,900 airplanes to be assigned, 0 A-10s. And Schwarzkopf looks at the list and he says, "Where's my A-10s?" And General Hornet says, we have F-16 specially armed, they'll do the job. Schwarzkopf looks at it, says, "I don't want to hear any of your Air Force political bullshit. Give me my A-10s."
The A-10s, aircraft that were at the time 20 years old, managed to outshine the 1,900 aircraft that had been chosen ahead of them, destroying 4,000 tactical targets, a tally higher than all the others combined. With such an impressive performance, why was the USAF so reluctant to bring the Warthog to war? What was it about this tank-busting machine that repulsed them so much? To understand the mystery of the A-10, we have to look back to the origins of the USAF. In World War I and II, the Air Force had been a branch of the U.S. Army. Over time, the role of the Air Force evolved with improved technology and battlefield experience. Aircraft could provide vital aerial intelligence, drop bombs on strategic targets, and move troops and equipment. One of the Air Force's most important jobs was providing close support for troops on the ground. That is, working closely with soldiers on the battlefield and executing the difficult mission of destroying enemy forces without causing casualties to nearby friendlies. As important as this mission was to the overall success of military campaigns, it was despised by many Air Force generals of the day.
From the day one, the United States Air Force going all the way back to the Army Air Corps, there has been this antipathy to the mission called close air support because it is tied to the Army or ground warfare. And it was a mission that did not fit their view of them being able to independently carry out whatever war that they wanted to and not be tied to what was going on the ground, not be tied to another service.
They very early on decided that what they needed to do to get a decent budget was to emphasize that bombing could win wars. That idea, a very false notion, by the way, still runs the Air Force today. They thought they could get much more money if they built bigger and fancier airplanes like bombers, and if they put out a tremendous amount of propaganda that bombers by themselves could win wars.
As much as the Air Force resented and resisted the close support mission, it was a necessary evil. Time and again, bombing alone proved ineffective at breaking the will of the people, whether it was Germany's blitz of Britain or endless bombing raids of the Allies against German targets. Allied ground forces supported by aircraft had the dirty job of taking back Europe mile by mile. Soldiers often found themselves mired in the quicksand of war, the situation shifting from minute to minute. They needed pilots tuned into the chaos of battle.
An infantry working outside the wire on a patrol, they want something above them that can see all, communicate with them, help them with their navigation problems, help them see ahead, and so they won't be surprised. And if they do get surprised and they come in contact, they can get almost immediate fire on the target. By immediate, I mean within a minute.
As much as the Air Force wanted to focus on bombing missions, they still managed to produce some legendary close support aircraft, albeit by blind luck.
The P-47, which was the original Thunderbolt, that airplane turned out to be a close support airplane totally by accident, which is typical of the Air Force. Since the Air Force didn't care to do close support, obviously they weren't going to design airplanes for it. They designed the P-47 as their approach to the greatest thing in the sky, to shoot down Messerschmitts. In fact, it was not the greatest thing in the sky to shoot down Messerschmitts. It racked up a very good combat record in air-to-air combat because it had some, fabulously good pilots, which count far more than airplanes. By pure accident, it turned out it was a wonderful close support machine because it had a huge radial cast iron engine right in front of the pilot, which was like built-in armor for him from the front. Could carry a big load because it was a big airplane, too big to be a good air-to-air fighter. And the engine was very survivable because it didn't have a liquid-cooled engine and radiator. So basically, rifle bullets couldn't bring it down very easily. The P-47 could come home with, 20 or 30 holes in it. And so it racked up a terrific record.
Close support was not considered the most glamorous job, but it was a vital one. The pilots of the 365th Fighter Group, also known as the Hellhawks, flew their P-47 Thunderbolts in one of the most important operations of the war.
It was realized in the Allied headquarters that they needed a tactical air force to support the ground troops directly during the process of the invasion of Normandy. So they needed a dedicated fleet of aircraft, both bombers, transport, and fighters, to seize control of the air and then support the ground troops. So the Hellhawks got drafted, probably not by choice, into that role. They dreamed of themselves as the high-flying pilots with a scarf streaming behind their neck, but they began to realize that they could play a crucial role on the battlefield, and they became very connected emotionally with the GIs on the ground and helping them out.
The Thunderbolt's impact would last long after World War II. The aircraft's success would set the mold for all future close support missions.
The importance of the P-47 and the Hellhawks and the way they use that airplane in combat is still with us today, 65 years later. Since World War II, with a few exceptions in Korea in the early days of that war, American ground troops have never fought without air superiority, without complete confidence that any aircraft they saw overhead was a friendly one. And that's a legacy of the P-47's ability to control the battlefield immediately over the front lines, where the fighting was heaviest.
As the war came to the close, a new weapon emerged which changed warfare forever. The dropping of atomic bombs sealed the fate of Japan in World War II. It also seemed to solidify the position of bomber generals who believed that bombing could win wars alone. The U.S. Air Force was in a powerful position, as it was the only service capable of delivering a bomb, albeit one constructed with the Navy's oversight. Though the Army and Navy were not enthused about sharing their budgets with a young competitor, and slowed and sabotaged the process wherever they could not stop the inevitable, and on September 18, 1947, an independent United States Air Force was born. Though the Army and Air Force were separate entities, the Army relied on aircraft to operate, to transport troops and equipment, and for the vital mission of close support. In 1947, a document was hammered out between the armed services to divide up the roles and missions of their respective fleets of aircraft.
The Army and the Air Force had negotiated a set of unbelievably bad agreements. I mean, bad for the taxpayer and bad for the soldier, called the Key West Agreements, by which they agreed to divvy up air assets. The Army would be in control of all helicopters, and the Air Force would be in control of all fixed-wing airplanes. And the deal was that the Air Force would not object to the Army getting very large numbers of these, would not object to them, doing armed versions of them, and in return the Air Force promised, we'll give you lots of close support.
A young colonel, Avery Kay, took part in these negotiations. He was a highly decorated and respected officer, having navigated the lead B-17 in the Schweinfurt raids, a treacherous mission to cripple Germany's industrial might. Colonel Kay soon realized that navigating through the politics stemming from the inter-service rivalries was no easier.
He was probably one of the most ethical officers I've ever known, a guy of enormous character and courage, almost to the extent of naivete, being just naive about what bureaucratic chicanery is all about. He came to realize within a year or two after having served in these negotiations and written some of this language where the Air Force promised to deliver close support, he realized the Air Force had no intention of ever delivering that support. And out of conscience, he felt personally responsible and guilty that the Air Force had not delivered and that he had personally participated in the lie. And he dedicated the rest of his career to creating a close support airplane that would deliver on the promises that he had been part of.
In just a few years, the USAF's short-sightedness when it came to close support became blatantly obvious. The Korean War was not decided with an atomic bomb blast. It was a grueling conventional war. Here, the USAF pinned their hopes on their speedy new jet fighters. They may have been state-of-the-art, but they were too fast and without the range to be effective close support aircraft. P-51 Mustangs left over from World War II were taken out of storage and shipped over as a makeshift solution. But these aging aircraft suffered heavy losses as their engines were vulnerable to ground fire. The Navy and Marines, with their A-1 Sky Raiders and F-4U Corsairs respectively, took the lion's share of the close support work, and they did so brilliantly.
Close support was of the essence, particularly when troops were moving, when we were moving forward, or when the Chinese were pouring over the border and driving us back. The A-1 was in fact a wonderful workhorse, shared the virtues of the P-47, had a big rotary engine up front to protect the pilot, was very hard to shoot down, you could put lots of holes in it, and because it had been designed to pull really big loads off carriers, had a very big wing which allowed it to maneuver very well at low speed. That airplane did brilliant work, particularly in the hands of the Navy squadrons that had it.
The USAF seemed blind to the lessons learned in Korea and oblivious to the idea that there might be another conventional war. In the years that followed, they continued to focus on building nuclear-armed bombers and jets in preparation for an atomic war with the Soviets. The Army realized that they might have to take the close support mission into their own hands. Chuck Myers recalls Army tests he participated in at Fort Rucker.
A lot of guys in the Army, particularly on the aviation side, felt that the Navy and the Air Force were not going to provide them what they needed, which they referred to as organic air support. The only option they had was somehow try to figure out how to do it with helicopters. And that's what was going on at Fort Rucker, was experimenting with helicopters. They were reinventing our old Army Air Corps. My primary helicopter that I was using was a H-13. They had strapped 30 caliber machine guns to the rails.
When hostilities boiled over in a tiny country in Southeast Asia, the USAF once again found themselves unprepared.
Well, what happened in Vietnam is we went into Vietnam and the Air Force, in particular with aircraft that were not suitable for the situations that we encountered.
In the skies, the USAF needed agile dogfighters capable of keeping up with Soviet-made MiGs. Instead, they had aircraft built to drop atomic bombs and fighters that lacked the basic cannon for shooting down opponents at close range. In terms of close support, they were just as ill-equipped as they had been for the Korean campaign. The USAF were forced to use ancient Navy A-1 Sky Raiders to take up the slack.
In Vietnam, the great hero of the war was the A-1 again. And the A-1 by that time had been sent to the boneyard. The Navy didn't want to hear about it. And somebody in Special Forces had the sense to see, we need that airplane, and convinced Secretary McNamara to bring A-1s back out of the boneyard, refurbish them.
Not surprisingly, the Air Force were less than enthusiastic about having the Sky Raider jammed down their throat by McNamara.
There was nothing that was more hated in the Air Force than to pull out a Navy airplane that had reciprocating engines, no jet, cruised at about 140 miles an hour, right? I mean, this was like anathema to the Air Force.
Though the Sky Raiders were an unwelcome gift from the Navy, they proved themselves again, just as they had in Korea.
The A-1 was a very fine bombing platform, and we could get close to the target and be far more accurate than they could with an F-100 who had to go up, drop his bombs, and get back home quickly before he ran out of fuel.
It saved probably several hundred CIA camps in the jungle that were being overrun, at night by VC and some North Vietnamese regulars.
It would take ultimate damage. Bernie Fisher, who landed during the Battle of Bash Shaw and picked up a lad who had crashed just off the runway. He had, I forget what, 20 or 30 bullet holes through that thing.
While the USAF was trudging forward in Vietnam with the Sky Raider, Colonel K, an advocate for close support aircraft, found himself in a new office with a clandestine mission.
Colonel Avery K. He wound up in 1966 in an office, a staff office to the Chief of Staff of the Air Force at the Pentagon headquarters called Concepts and Doctrine. Concepts and Doctrine was a smokescreen. What it really was about was a term of art in the military called roles and missions. What roles and missions means is your job is to defend the Air Force budget against raids by the Army and by the Navy.
At the time, the U.S. Army was in development of a costly new helicopter called the Cheyenne. It was built for the mission that the USAF detested, close support. 50% more than the Air Force's most expensive fighter, the F-4, Kay recognized that the Cheyenne was a threat to the Air Force's budget. He also saw an opportunity to leverage the situation to fulfill the Air Force's old promise to the Army.
He realized, if the Army does this, if the Army builds this super expensive $4.5 million helicopter, they're going to want 1,000 of them at least. Where's the money going to come from? It's going to come out of the Air Force budget. Perfectly correct perception. He also perceived that this would be a powerful incentive for the Chief of Staff to develop a close support airplane to make sure that the Army didn't get all that money.
Kay's plan of creating a close support aircraft to thwart the Cheyenne filtered its way up to the Chief of Staff of the time, John P. McConnell. Though McConnell was a bomber general and loathed the close support mission, he had fears about relinquishing it to the Army.
If you let the Army get away with that Cheyenne helicopter, that costs 50% more than our most expensive fighter, that money's going to come out of your hide, and you're going to go down in history as the Chief of Staff who gave up the close support mission. Of course, no Chief of Staff wants to do that. They're all very worried about their legacy. March on, start developing a close support airplane, make sure it's cheaper than the Cheyenne, and make sure it's much more lethal and much more survivable, so that we have a real case that the money should go to our airplane.
Given the green light to create the USAF's first purpose-built close support plane, Colonel Kay had to build the brain trust that would help shape the aircraft specifications. At the time, Pierre Sprey was working for Secretary of Defense McNamara, analyzing the USAF's aircraft inventory in Europe.
I've been assigned to do, are we wasting our money on airplanes in Europe? Are we doing the right thing? Are we buying the right fighters to stop 90 or 100 divisions of Soviets from sweeping over Europe? That was the number one threat in the U.S. military strategy at that point. My conclusion was, we are wasting our money. We need to stop buying so many bombing airplanes. At that time it was called interdiction. We need to focus on close support, on actually helping our defending tank troops and anti-armor and so on with airplanes that can do the job right at the point of battle. That made me public enemy number one of the Air Force instantly.
Realizing he had found a like-minded maverick in Pierre Sprey, Colonel Kay approached him about joining his team.
He says, Mr. Sprey, I've read your paper. I see that you're a big supporter of close support and you think we should be spending lots more money on it. I've been assigned through my boss, and the Chief of Staff has approved that we start a great close support airplane. He says, I'm stuck because the entire Air Force is sabotaging me. Because the rest of them don't want to do it, just the Chief of Staff. And we badly need help. We have no real technical people. Will you help us? There was no way in conscience that I could turn him down. It was such an absolutely correct thing to do and so badly needed. I said, I'll help you in any way I can.
To help Sprey and Colonel Kay develop the ultimate close support aircraft, they enlisted the help of A-1 pilots fresh out of Vietnam. Their first-hand experience working with the Army would prove invaluable in creating the new aircraft, then simply known as AX. Tom Christie, who helped examine potential contenders for the AX's weaponry, recalls the passion of Kay's group.
And so I can remember coming up to Washington, TDY, from Eglin Air Force Base, which I did quite often, and meeting with Pierre Sprey, 8 or 9 o'clock at night in the Pentagon, and I'd show up and he'd have 5 or 6 Air Force officers, that were part of this cabal. And the one in particular that I remember was a guy that named AVK, and they wanted to make sure that the Air Force did not go wandering off and make the same mistakes they'd made in previous years. They wanted an aircraft that was dedicated to and designed for close air support.
The interesting thing is, you would have imagined that an airplane born in this kind of sin, designed to simply kill an Army helicopter, couldn't possibly become a good airplane. But the interesting thing is, for us down in the trenches trying to shape this airplane, once we had the Chief of Staff's approval, is these were absolutely ideal circumstances for creating a really good airplane at very low cost. I mean, normally you're told include this technology, you got to include that radar, you got to include this piece of junk, make sure it's plenty expensive so that the contractors get lots of money. Whatever you do, don't make it cheaper than the last airplane. That's what really shapes airplanes today. We have the dead opposite, because our instructions were make the airplane much more lethal, much more obviously lethal than the Cheyenne helicopter, make it much cheaper, and make it much more survivable. That's exactly what you want to do for a close support airplane. So out of the political mayhem of the Pentagon budget battles, we actually had marching instructions that, the designers would kill for.
Pierre Sprey, Tom Christie, and Chuck Myers all pushed for the development of America's first close support plane. In the 1970s, these renegades would bond into a group known as the Fighter Mafia. Together with other like-minded officers and defense analysts, they battled against the establishment to help create the best aircraft to meet the demands of war within the restraints of the government's purse. Though they had their critics, more often than not, the Fighter Mafia were proven to be right. Sprey worked closely with contractors, including Northrop and Fairchild, and reviewed hundreds of designs in the quest to make the ultimate close support plane. But what exactly are the ingredients of such an aircraft?
The primary things you have to be able to maneuver very well at low speed, and that's both to get close to the target so you can distinguish friends from enemies, you can pick up things that the ground guys can't see, and very important, particularly since some of this focus was on Europe, you have to be able to fly under weather. When you've got clouds at 1,000 feet, 500-knot jets become hopeless. You have clouds at 1,000 feet and you have hills that are 500 feet high, and you try to come booming down through those clouds at 500 knots. That's simply not feasible.
The aircraft also needed to be capable of loitering over targets for extended periods, at least 2 and hopefully 4 hours with a full bomb load, 250 miles from base. If a plane had to leave the battle to refuel after just a few short minutes, it wouldn't be around long enough to provide any real support. The A-1 pilots were adamant about this, and about the need for an excellent radio communication system.
You had to have great communications. This was in a day, and by the way, that day extends to today, when essentially no Air Force airplane could talk to the ground. They had radios that deliberately could only talk to other Air Force airplanes or to headquarters or to Air Force radar airplanes, and no direct way to talk to a guy, holding a small tactical radio sitting in a foxhole. My A-1 guys were so insistent on that, they just pounded it into me every day. You can give up anything else, don't give up those radios. That's how important they were.
Another key element of close support aircraft is survivability. Pilots going on such a treacherous mission, close to enemy fire, need to have a reasonable chance of coming back in one piece.
You can't ask pilots to go into an environment this dangerous to airplanes if you can't guarantee them that they're going to, for the most part, get home. And so we put a huge amount of work into survivability.
There was so much attention paid to the aircraft being able to survive in what was forecast to be a very critical environment that we were going to be flying in with a lot of air defenses. In particular, the 23mm gun system that the Soviets allegedly were fielding in great numbers.
You put a .22 rifle into any modern jet, a .22 rifle bullet into any modern jet, and it will penetrate the tank, will very likely create a leak or light a fire, and the leak itself will catch on fire if it's right next to the engine.
Well, a lot of attention, unprecedented attention was paid to that whole concept of reducing the vulnerable areas. Being given a hit, will you go down or not?
A plethora of survivability specifications were laid out for the AX. Using cables rather than flammable hydraulics to control the flaps and other control surfaces, and building the structure of the aircraft the old-fashioned way, with spars covered by skin. A feature that allowed the old A-1s to return home with gaping holes in their wings. But perhaps the greatest feature of the AX was, of all things, a titanium bathtub.
We demanded armor, essentially completely around the pilot, certainly up to this level, from the front, the back, and everywhere, that would stop an American .50 caliber bullet or the Russian equivalent. And that led to a 2,000-pound titanium bathtub. They still call it the bathtub to this day, and the pilots love it, because it gives them all kinds of confidence when they're pressing an attack and they're hearing impacts of bullets on the airplane and so on.
As important as survivability was, the AX was an offensive weapon, built to destroy tanks. The whole of the aircraft was designed around a massive gun capable of blowing away the competition. While designing the gun specs, Spray looked for inspiration from a most unusual source, a hero of Nazi Germany. In the 1960s, the U.S. Air Force had a helicopter in their crosshairs. Surprisingly, it did not belong to one of its opponents behind the Iron Curtain, but rather the U.S. Army. The costly Cheyenne helicopter, built by the Army to support its troops, was seen as a potential drain on the Air Force's own projects. To counter this rotorcraft, the Air Force began drawing up the specifications for a new close support plane known as the AX. It was an aircraft and mission the Air Force really didn't want. However, the team at the Pentagon behind the AX saw things differently. They saw supporting troops on the ground as one of the most important missions, and they set about to build what would become one of the Air Force's most lethal weapons. The AX was an offensive weapon, built to destroy tanks, armored personnel carriers, and soldiers entrenched in foxholes or behind sandbags. The whole of the aircraft was to be designed around a massive gun capable of blowing away the competition. While designing the gun specs, defense analyst Pierre Spray looked for an inspiration from a most unusual source, a hero of Nazi Germany.
Because I was adamant that we had to do this purely from the point of view of the effectiveness demanded by combat experience, I assigned everybody on the team to read a book called Stuka Pilot by Colonel Hans Ulrich Rudel, because I had found nothing in the entire literature on close support that gave a more precise and more objective view of what close support is really about.
Rudel flew an incredible 2,500 missions where he rained havoc on opposing armies, destroying an astonishing number of enemy vehicles, including 519 tanks. His tank-busting aircraft of choice was a specially modified Stuka, armed with two 37mm cannons. Spray began a worldwide search for a caliber of bullet powerful enough to pierce Soviet tank armor, while not so large as to make it unwieldy for an aircraft to fire. He found the perfect bullet in the land of fine chocolate and watches, Switzerland. Munitions manufacturer Oerlikon produced a devastating 30mm round, which penetrated with Swiss watch-like precision. Now that Spray had found his bullet, he had to figure out a way to fit 1,000 rounds worth on the AX. The massive amount of ammo was housed in a drum 3/4 the size of a Volkswagen.
Of course, when we started sizing the weapon, see how big it was, a huge ammunition storage, because we wanted enough ammunition for 20 repeated passes. See, that was part of the long loiter, long endurance. It's not just hanging around, you also have to hang around and be dangerous, have weapons.
Carrying so much ammo in such a powerful weapon, the AX might be best described as a flying piece of artillery. Though the 30mm shells were potent and capable of penetrating the thick Soviet armor, they wouldn't necessarily stop a tank in its tracks. At that time, a new type of bullet was in development which packed a depleted uranium punch.
Depleted uranium has exactly the same properties as magnesium. When you hit with a high velocity, you actually light off the metal. The metal burns inextinguishably, just like magnesium does in a flare. This thing is so incendiary that if you just have grease, the normal grease that's in the sump under the engine, you're very likely to light the tank on fire because there's burning fragments everywhere once you've penetrated.
By 1970, Spray and his team had put together all the specifications for their AX aircraft into a concept formulation package. The tremendous amount of work they did paid off. The USAF, still eager to kill the Cheyenne helicopter, approved the plans, as did Secretary of Defense McNamara and Congress. The U.S. Army with the Cheyenne and the USAF with the AX weren't the only ones fighting for a piece of the government spending pie. The Marines had a futuristic close-support aircraft of their own, the AV-8 Harrier. Chuck Myers took part in an evaluation of the three designs.
The group leader turned to me and said, well, we need a plan. Who are we going to visit? Who are we going to talk to about this subject? And I said, well, I think we probably ought to start with the Marine Corps because they probably know more about the subject than anybody else. I had great interest in air support. I set up the meetings for them over at Marine Corps headquarters, and our little group went over there, and we spent a whole morning listening to Marine Corps expound on the subject. And of course they were pushing this thing called a Harrier, which, if I could think of an airplane least appropriate for close air support, that would be it, because of its vulnerability to small arms fire.
Myers soon realized the bomber generals in the USAF weren't the only ones who had antipathy for the close support mission.
We all convened for lunch, and it broke up into little groups, and I remember sitting at a round table having lunch with a couple of Marines, and one of them was a colonel. And I never forget the colonel saying, he thumped the table and said, boy, we can hardly wait to get our F-14s. And the other guys in my group looked at me like, they're F-14s. They were no more interested in close air support. All they could think of was they were going to get the F-14 along with the Navy. Everybody wants to fly fighters. Nobody really wants to do this horseshit mission down there in the dirt.
While Congress evaluated the aircraft available for the close support mission, Spray's paper airplanes were turned into prototypes. When it came to testing, Spray once again carved his own path.
I had felt very strongly all along that the right way to do this was to get prototypes built, 2 or 3 prototypes by each company, and have a real firing shoot-off, a competition, a fly-off.
The A-9, A-10 were the 2 entries into the AX program, which was our first foray into a fly-off. That was a different approach. The 4 aircraft, 2 from each company, were flown over a period of many months at Edwards Air Force Base.
That had never been done in the Air Force before. They built lots of prototypes, and people were very reminiscent and very nostalgic about how great it was when we built one, but they never flew against each other. They were kind of engineering models. They went to Edwards Air Force Base, the test pilots flew them, clocked how fast they flew, how long, how high, how fast, and then kind of on paper compared them to other airplanes. We didn't want that. We wanted a real competition where you went and did the mission as realistically as you could with 2 manufacturers fighting it out, and the guy who did the mission best would win.
Northrop and Fairchild Republic were given a little over a year to construct 3 prototypes each, 2 flying and 1 in pieces just for test fire experiments. The possibility of being struck by ground fire was a reality of the close support mission, something not factored into the designs of most jets of the era, which made them vulnerable to attack. Spray challenged aircraft manufacturers Northrop and Fairchild to design planes which kept the volatile fuel supply and the hot-burning engines as far away from each other as possible. While Northrop buried the engines next to the fuselage, Fairchild came up with their own innovative solution.
Fairchild came up with a superb solution. They have the engines out on pylons away from the fuselage. There's no fuel between the engines. All the fuel is way forward in the wings, and it's brought a lot of pilots home. There would have been in airplanes that were burning and crashing.
Spray once again rattled the establishment, this time with his choice of test pilots.
We had the shoot-off at Edwards Air Force Base. Half the pilots were test pilots. This was another huge battle. Half of them were fighter pilots, real pilots, which was crucial because we were going to do so much bombing and strafing. That's not something that test pilots, are particularly adept at. So that was another revolution, another bureaucratic mess, because of course the test pilot community has their own little sacred cows.
So these 2 airplanes were flown first by company pilots and then turned over to a team from the Air Force to go through a whole procedure in flight and in other logistics analyses, the whole ball of wax.
It was an extremely close competition between Northrop's A-9 and Fairchild's A-10. It was hard to choose a winner before counting up all the bullet holes and tallying up the scores on each test.
I had thought that Northrop was going to win because they had a somewhat slicker design, a little better aerodynamics. And lo and behold, after all the shooting was done and all the testing, Fairchild had taken the survivability a little more seriously, had an edge there, had a slight edge on some of the accuracy, dive bombing accuracy stuff, and they were awarded the contract. And it's exactly what's supposed to happen. The guy you didn't think was going to win won because he did a little better. It was pretty close though. It was a really tight race. We wouldn't have been badly served by either airplane.
The A-10 Thunderbolt II was named after another legendary close support aircraft, the P-47 Thunderbolt. The A-10 was an excellent design, but Fairchild still had to work out some serious technical issues.
We were doing all the follow-on tests on the A-10, primarily gunfire. Because when you were firing guns, the engines would quit. And when the engines would quit, it would be very quiet. I mean, you didn't hear, it wasn't like a compressor stall where it makes a lot of noise. It would just, the temperatures would go up on the engines and ruin them, or and the RPM would come down. So I flew thousands and thousands of rounds at the ground to try to solve this engine problem. The problem with the A-10 with the engines were twofold. One, with the gun gas going in the engines and causing the engine to quit. The other one was pulling high angle of attack or high turn rates, because the airplane had good handling quality, so nothing bad happened aerodynamically. But the engines couldn't stand the lack of the air. So the solution to both problems was to put continuous ignition on the trigger. So anytime you fired that, the continuous ignition came on to both engines. So if it quit, it restarted immediately. And also high angle of attack, on angle of attack. So ignition comes on at high angle of attack. The engines keep running. Well, they don't keep running, but the pilot doesn't know the difference.
With the A-10 selected for production, the Air Force found itself in an unpleasant situation. Their motive for supporting the A-10 was always to kill the Army's Cheyenne. In 1972, that became a reality. With the Cheyenne dead, they suddenly had a new close support plane in their hands, an aircraft they really didn't want for a mission they despised.
1972, the Cheyenne was safely dead. It had been killed. The Air Force had accomplished its mission, and now started an unending series of assaults to kill the A-10. There wasn't a month that went by that some general didn't have some idea about how to kill the A-10.
The Air Force felt the A-10 was primarily supporting the Army, and they really didn't want that mission. In fact, at one point in time, they were talking about giving the A-10s to the Army. But then the Air Force decided that was their mission is to fly airplanes and not the Army's mission. So that got to be controversial. So the Air Force said, okay, we'll support the Army.
Air Force generals got together with an airplane manufacturer in Texas, Ling Technical Vought, the old Chance Vought company that had been building A-7s for Vietnam. A pretty poor bombing airplane, highly vulnerable, full of flammable hydraulics and all that. And they claimed that they had a model that would do close support superbly. They got some congressmen to back them, along with these Air Force generals, and they actually forced us to do a fly-off of the A-7 against the then still in development A-10. So we dragged out the Y-A-10, the prototype, and had a little fly-off. The A-7 was so laughably worse that nobody could pretend that this was a good excuse for killing the A-10.
The A-10 seemed to be equally resistant to battle damage as it was from assaults from the Air Force. Production continued, and in March of 1976, the 355th Tactical Training Wing, based at Davis-Monthan Air Force Base, Arizona, became the first unit to receive the A-10 Thunderbolt II. This did not dissuade the Air Force from continuing to do all it could to whittle production numbers.
Interestingly enough, the Reagan administration comes in And as I recall, the A-10, we had a procurement goal of 733 airplanes, something like that total. We had one more year to go. And the Reagan administration rolls in and, of course, throws money at everything the services wanted. And then Stockman, recall Mr. Stockman, who was OMB at the time, sort of said, my God, we need to take a look at all this money we're spending. You know, we're going in the whole tax cuts and all that. So he took aim on the defense budget.
Stockman, the director of the Office of Management and Budget, battled with Secretary of Defense Caspar Weinberger over Reagan's bloated defense budget. A compromise was reached, which would leave A-10 production in the crosshairs.
And Weinberger came back and said, hey, we got to show that we're stewards of the budget, so we need to cut some things. Lo and behold, what does the Air Force offer up? The last year of A-10 production, I think it was a smaller number. We had been up to, I think, 144 aircraft a year. And they also tried to cancel the ammo procurement. Unbelievable. They didn't get away with that.
It wasn't just the Air Force brass who had misgivings about the A-10. Pilots of the day would have preferred to be flying the latest supersonic fighters, but it didn't take long for them to come around.
The guys who joined the A-10 community for one reason or another, a lot of them were there as punishment tours because it wasn't a glamorous tour for anybody. But they became committed to the airplane. The more they learned about the airplane, the mission, what it takes to help guys on the ground, how demanding the mission is, because it takes an enormous order of skill. I mean, it takes a whole set of skills air-to-air pilots don't even dream of. It's a totally different world. And they became dedicated to that world. And then, actually, you know, a bunch of wars came along where they could actually exercise those skills and refine them. And what's interesting is they had the same opposition from the Air Force in the wars as we had when we were trying to produce the airplane.
The A-10's first combat mission was the invasion of Panama in 1989, when the U.S. ousted Panamanian dictator Manuel Noriega. Though the aircraft faced no real resistance, it would soon have an opportunity to prove itself fully. On August 2, 1990, Saddam Hussein invaded Kuwait. There was international condemnation of the event, and the Iraqi dictator was given a hard deadline of January 15, 1991 to withdraw his army. Coalition forces built an impressive armada of weapons to push Hussein out of Kuwait, including 1,900 aircraft. Curiously, General Hornet, commander of air operations, almost left the A-10 behind.
General Hornet was called in by General Schwarzkopf. It was before the actual assault launch. And Schwarzkopf looks at the list and he says, where's my A-10s? And General Hornet says, we have F-16 specially armed, they'll do the job. Schwarzkopf looks at it, says, I don't want to hear any of your Air Force political bullshit. Give me my A-10s.
General Schwarzkopf recognized the abilities of the A-10 as a tank buster and close support plane. It had been built to destroy Soviet tanks, and the Iraqis had more than 5,000 of them. He made a wise choice. The A-10 destroyed more tactical targets than all other aircraft combined. Even General Hornet could not deny the A-10's excellence, at least temporarily.
The A-10s did such a good job of bailing out the failures of other airplanes that the same General Hornet who had refused to deliver A-10s at the beginning of the war said, right in the middle of his staff in the famous black hole bunker in Saudi Arabia that was commanding the whole air war, after he saw the results of the A-10s, particularly even in wiping out missile sites, mind you, which they'd never been intended to do, he said, I take back every bad thing I said about the A-10. They saved our asses. And that was heard by a whole bunch of staff members, has been widely quoted since then. Now here's the interesting thing. After the war, when everything had died down, people had done the battle damage assessment, and by the way, the Air Force had totally suppressed the successes of the A-10 that I just quoted, and had put out a whole bunch of junk about how brilliantly the F-117 did and all this. This is all hogwash. General Hornet was forced by his fellow generals to renege on what he had said and joined the assaults on the A-10. You know, actually went back on what he had said about how they saved our asses. He said, no, they weren't that important. Now you ask yourself, how could a guy who had spent his career, you know, flying airplanes, he'd flown a lot of fighters, he wasn't just a bomber guy. But once he got to be a general, he was so infected by the culture around him of the other general officers. And that culture, dating again back to the 1920s, was a bomber culture. It's, you know, we bomb targets that we assign to our Air Force. We do it independently of the Army. We do it with airplanes that are very expensive because they're good for getting us a bigger budget. And that's what the Air Force is about.
Though the A-10 had done excellent work against Iraqi forces, by the end of the first Gulf War, the Air Force should have had a replacement in the pipeline. Aircraft have long gestation periods, and the A-10 was based on 1970s technology. But the bomber culture that permeated the upper echelons of the Air Force made a new aircraft nearly impossible.
A lot of the people in the close support community, the military reform community, in 1983 started proposing developing a far better, far more modern A-10. You know, we called it variously the Mud Fighter or the Blitz Fighter. And it was going to be smaller, hotter, much better maneuverability, better able to get close in, better able to survive, have even more lethal weapons than the A-10, and we were ambitious to make it even cheaper than the A-10. And we had designs laid out, and we briefed them all over the Pentagon, and the Air Force came down like one man to kill it.
The Air Force went bonkers. When they found out that Lockheed at Marietta, there were people down there doing some work on that, they told Lockheed, either you back off this and stop all this, or you don't have a prayer's chance of competing with what was coming down the road, which was the Advanced Tactical Fighter, which became the F-22. So they stopped.
To put the final nail in this new aircraft's coffin, the Air Force offered a compromise of sorts.
An Air Force two-star came down and said, okay, we want to sign a peace treaty. You guys back off pushing this new aircraft, okay? You do that, and we promise we will back off retiring A-10s. Not only that, we will upgrade them. So we agreed. So they did. They took away the planned retirement, so which was to start probably in 1990-91.
Without a replacement, close support pilots were forced to soldier on with aging A-10s. Now the Air Force had a new excuse to rid themselves of the A-10. It was too old.
Nothing changes about these assaults. The first one is always, the airplane is so old, you know. It's aging, it's decrepit, it's going to cost a lot to maintain. It's a perfectly silly argument. First of all, the A-10 is not the only old airplane in the Air Force. The Air Force generals are defending a far older airplane, the B-52. It's okay, we've so refurbished and remodernized it, even if it is older than all the pilots, who cares? Well, oddly enough, the same thing is true of the A-10. The A-10 had been heavily refurbished. In fact, it's an amazingly modern airplane now. First of all, most of the fleet has been re-winged, although the Air Force is now trying to steal that money for the F-35, the re-winging money. But most of them have already been re-winged and will be good to 2040. You know, secondly, it's completely false that older airplanes get more expensive to maintain. The older airplanes, B-52 included, are vastly cheaper to maintain than any of the new airplanes that replace them. And they're just like old cars. If you find somebody to make the parts, you can keep a car going forever, and people who love the car do.
As the airplane stands today, there's nothing that can touch it in terms of performing this mission. There's just no way. It can do all the things that the ultra high-tech systems can, like F-15s and F-18s and so on. It can do all those things just as well as they can, but it can work the other end of the spectrum down low. In lack of anything else, I would open the line and build more A-10s.
From the invasion of Iraq to Afghanistan to the war against ISIS, the Air Force has been equally reluctant to bring the raging warrior to battle with them. Though the A-10s took part in the initial assault on Iraq, they were mothballed from 2003 to 2007. The USAF tried to rely on F-16s and other fighters to hit targets on the ground, but they were often inaccurate and caused casualties amongst friendlies. It wasn't until 2007 that the Air Force was forced to concede they still needed the A-10, an aircraft originally designed for a jungle war.
The A-10 was a Vietnam follow-on because all the airplanes in Vietnam didn't have much fuel to stay around the target area. And of course, Vietnam was over, but it turns out now that the A-10 was perfect for Iraq and Afghanistan because it can loiter for long times. It's got plenty of ammo. That gun is absolutely outstanding as far as the 30 millimeter. You put the pepper on the target and the first dozen bullets go there. You know, no question. That's where they go.
Like the USAF, the Russian Air Force has a dedicated ground support aircraft of their own, the Sukhoi Su-25, an aircraft with an uncanny resemblance to Northrop's A-9. Introduced in 1981, it is still in production, and with multiple upgrades it continues to support Russian troops and the troops of buyers from around the world. The Russian Air Force does not seem to have the same hang-ups about close support as the USAF, and in 2015, the Su-25 was brought into Syria to combat ISIS. Rather than create a new dedicated close support aircraft, the USAF is pinning their hopes and dollars on stealth multi-role fighter, the F-35. This versatile aircraft was designed to handle the missions of not only the A-10, but also the F-16 and F-18 and AV-8 for the USAF, Navy, and Marines. Critics of the A-10 label it a single-purpose aircraft, but could a jack-of-all-trades master any of these missions?
Here we are now with the A-10, obviously now 40 years old, 30 to 40 years old, though it's still got life. And we have one program going, F-35, and that's going to fill all these missions. And that's just outrageous to even, think about that.
Multitasking is a huge waste of money because it leads to enormously expensive airplanes. Instead of that $250 million airplane, we could have a great close support airplane for $20 million or $25 million. We could have a great fighter, air-to-air fighter, for $30 or $35 million. And then we could have whatever else you need, a reconnaissance airplane or those other kind of missions that maybe it does. We could have one of those for $30 or $35 million.
It's uncertain when the F-35 will be able to take over for the A-10 and how effective it will be. Though the A-10s have been upgraded into the most advanced close support aircraft in the world, the USAF is almost embarrassed to bring them to front lines as they battle ISIS and prepare for a potential conflict in the Ukraine.
I agree with the Air Force, It is a disgrace that we're flying that ancient airplane, and it's their fault. Because we should have been started, by the mid-'80s, we should have been started prototyping something that was better than the A-10, and then let it prove that it was better. If it wasn't better, then we wouldn't build it. We never did that because the Air Force never wanted to do that mission.
Over the years, the A-10 has proven itself the premier close support aircraft in the world. Sadly, it has also become a symbol of the strife between the branches of the armed services. The A-10 was authorized by the Air Force as a means to destroy an Army helicopter. Though it ended up doing an exceptional job supporting the Army, from day one it has been under attack from within. The A-10 still has its detractors, but the resilient aircraft is ready to prove itself if given the chance. As each branch fights for its share of the defense budget, perhaps they are blinded to the bigger picture, that they are at war with their enemies, not each other.